Greetings, folks. I'm Shah, Director of Engineering and Operations for Oxygen Health Systems. Today, we're going to be showing you how the chamber operates along with its components. Now, the type of chamber I have behind me is the 34-inch 2.0 with progressive control. Now, you may have something slightly different. That matters not. What matters is that we focus on the basic operation of the equipment today, and we will deal with those slightest of variation at a later time. So once again, what we have is a 34-inch 2.0 with progressive control. Progressive control would show you multiple buttons, 5 to be exact. And then besides that, we have to my left the air conditioning unit and then the all-in-one unit. So basic unit, the air conditioning unit, which is part of a dual action AC, the external compressor, and then the internal condensing unit, which is right at the foot of the chamber. And then we have the all-in-one unit. The purpose of the all-in-one unit is the compressor that provides the compression to the chamber, as well as producing the oxygen, or otherwise known as the oxygen concentrator. The capacity of the oxygen concentrator is 10 liters per minute. It's a continuous flow as opposed to pulsed. And then the capacity of the all-in-one unit, the air compressor, is 70 liters per minute. That provides the compression into the chamber. Now, let's start from my right to left, the different components and hardware that is attached to the chamber. Right behind me, so the pressure gauge right here is the blue pressure gauge, and that's the external pressure gauge. And if you take a look, you would see that the scale is kPa, which stands for kilopascal. It goes from 0 to 250. However, our chamber would be pressurized to 100 kilopascal. Next, we have the open-close valve, and this is a bidirectional open-close valve. Notice how intuitive it is. Close clockwise, open counterclockwise. Now, considering it's bidirectional, meaning anything that you do from outside, you should be able to do that from inside. Of course, in order to close from outside, it would be clockwise. On the contrary, if you're inside, it would be counterclockwise, since it's bidirectional. Next, we have the emergency pressure release valve, and that should only be pressed from inside. That says push from inside in the event of an emergency only and no other times. Next, what we have here is the golf ball grip. Notice there's a grip that looks like just like half a golf ball, and hence we call the golf ball grip. Now, considering that the chamber door, the metal mechanism, has magnet in them, you will hear a clicking noise like that, which shows you it is the magnet that is grabbing the metal, two pieces. Hence, you'll have to exert between 5 to 7 pounds of pressure gently, between 5 to 7 pounds of pressure, and then slide from this side to the right, and you would see that the door would just open freely. Once again, here is the door. Notice how easily it's moving, closing, and then 5 to 7 pounds of pressure exerted here. I'm opening that door. Okay, now let's move right along. We have the two handlebar right here. These two handlebars are the bars that you would use in order to enter and exit the chamber. No other parts, such as these, internal door mechanism, or any of these here, or these metal parts should be touched in order to get in or out. You may see a little braid here. That should be only used for hanging a light or perhaps a phone and nothing else. Nothing should be pulled. None of this should be touched except for this golf ball. And that's pretty much it. Next, we have the external control panel. Once again, the external control panel is for progressive control, and hence you'd have the progressively upward pressure such as 1.3, 1.5, 1.6, 1.8, and 2.0. As you select this pressure, you would see these buttons lighting up, and we will give you the demo. Barring that, you also have the pressure on and off button, oxygen on off button, then we have the timer button, which we recommend that you keep always at 12 noon, always at 12 noon position. Then we have on the very far right side, you have the on-off button, which you hold on to it for 3 seconds for it to be turned on. And I'll give you a demo. Here it is. Turn on the machine, come here, hold on to it for 3 seconds. Notice you hear an audible beep, and now we will go over these displays. Notice, we will start from the top right quadrant. So top right quadrant is percentage humidity, and that's why it says percentage RH. We're in Chicago, this is winter months, 26% relative humidity. Next, bottom right quadrant. Notice that it's 21% oxygen. As we know from our basic chemistry in high school or university, 21% is the constituent of oxygen in 78% nitrogen and some inert gases. Once again, 78% nitrogen, 21% oxygen at sea level at zero pressure, 1 atm, and then at the left corner is the pressure, and that's 0 kPa. Recap, top left, temperature in centigrade. Top right, percentage relative humidity, which is 26% now in Chicago today. Bottom right, 21% oxygen. Bottom left, 0 kilopascal. So if you, it just turned out to be 1. So in case you see that it is a little bit off, all you have to do is hit this button 3 times in 2 seconds, and that should turn to 0. Oh, turn to 0. So I'll give you a demo. So what you would do is you press 3 times in 2 seconds if any of these things are off. Let's say this is not 21%, it's reading 32%, 27%. In order to reset that at 0 pressure, you would hit it 3 times in 2 seconds. Here we go. Notice the long audible beep, wait 5 to 10 seconds, and then it would turn 0 and 21. Okay, I think we've explained that enough. Let's move on. We also have communication system that you would use to communicate with your client inside, your patient inside. And it's a two-way. That means you would be able to communicate from here as well as inside. And speaking of inside, let's go show the inside communication unit as well as anything that you can do from here, how that is replicated inside using a similar control panel known as the internal control panel. So notice the large version external control panel, and its miniature version is the internal control panel. And here it is. As I was stating, the external control panel and its function, whatever you can do, its miniature version is right here. So we were talking about the external handset or phone. That phone, if someone picks up from outside, should be ringing right here. In reciprocity, if you press that button right there, the outside phone or the handle unit would ring. So it's a bidirectional unit. Now, let's get familiarized with all of these buttons. Let's start with the vertical line of buttons, which are located right here. The first one is the ionizer, and when anything is on, you would have an electric blue background. Notice, I will take my finger, it's a toggle. I'll put my finger and then take my finger off, and off goes the electric blue. Now, I press that again. As I stated, it's a toggle, so the electric blue came on. Next is the internal fan. Now, when you press that internal fan, expect the same thing. Let's see whether it does that. Here we go. And I just noticed the electric blue came on, and to my right, I heard the fan kicking in. So that's the internal fan, which is paired with the external compressor. the part of the AC dual action system. Last one is the alarm. We're not going to go over that. It's only in the event of an alarm that you would, use it. But anyway, let's turn the AC off. Notice that you have the muffler port right here. This is where the condensation cup is attached. In the event you have water accumulation, all you do is unscrew, drain the water from the condensation cup, wipe it down with alcohol, and put it back. Next, you have the emergency mechanism in the event after depressurizing the chamber door still doesn't open. The banana wing nut or butterfly nut is something that you'll have to unscrew and then push that button, and that will cause the door to release only in the event of an emergency if the door doesn't drop. After that, you need to put it back or reactuate the mechanism by pulling the black lever and then tightening the banana wing nut into its respective slot. If you have any further questions, we can go over that at a later time, but beyond the scope of this training, we will leave it at here. Next, you have the oxygen breathing unit. There, you would attach your nasal cannula or face mask or any other facial apparatus that you need to in order to use the oxygen. Also notice that you have an internal pressure gauge. As I've pointed out earlier, you have a blue external pressure gauge, and here you have the black pressure gauge, which reads from in the counterclockwise direction. The external pressure gauge reads from in clockwise direction, and the internal pressure gauge, which is black, reads counterclockwise. Okay, here's the function of the open-close valve. Remember, I pointed out from outside, in order to open the valve, from outside I would turn it clockwise. That means from inside it would be counterclockwise. And from outside, if I want to open the valve, I would turn it counterclockwise, but from inside it would be clockwise. So that's the function. The average deflation time is 5 to 7 minutes, which we will go over at a later time. But just know it is a bidirectional valve, and it can be operated both from inside and outside. Now, let's focus on the emergency pressure release valve. Once again, I stated that the emergency pressure release valve can only be pressed during emergency only and no other time. Also, I said that in the event of an emergency, you would push and hold on pushing the button. Let's do a demo. So here I go. And then I hold on to it. The moment I let that go, the spring pops out, the emergency pressure release valve. And there is one more piece of information that we need to share with you, and that is, besides it being the emergency pressure release valve, it is also a tertiary pressure release valve. If this chamber is rated at 2.0, you have two 2.0 valves, one acting as primary pressure release valve, the other one working as a secondary pressure release valve, meaning once the chamber reaches the pressure of 2.0, should the primary fail to operate in terms of releasing the excess pressure above 2.0, it is the secondary pressure release valve that would take charge. Furthermore, if the secondary pressure release valve fail to operate, then it is this tertiary pressure release valve that would operate at 2.1 kPa. So as you know, it has multiple functions. The buttons that are outside on the external control panel, which is oxygen and the pressure, as I stated, it has been replicated also inside. Once again, this entire function in its miniature version has been replicated inside. So now let's take a look. The oxygen button is this yellow button. The pressure button is the red button. Now, when you press this, it will turn green, right here, the green LED. When you press that and the pressurization begins, it will turn green. And the internal light is the middle button, and that has no green LED. Once again, yellow, that is your oxygen, and upon pressing it, it will turn green. Pressurization, red button to the far left, and once you press that, it will turn green. And the middle button, which is also the light green color, is just the internal light, and it doesn't have an LED. And here's the proof. No LED, but the internal turned bright. In order to turn the oxygen machine on, you'd have to first close the door. Hear the 3 short confirmation beeps, and then with this oxygen concentrator button turned on, which we already have done, then you would press this button. And the moment you turn this button on, you would hear the oxygen flow, and then that will in turn begin the oxygen supply from the oxygen port, which is connected to your facial mask or nasal cannula. Once you have the oxygen turned on, your next step would be to make sure that you have closed the open-close valve, which is right here. So we're about to begin the operation or pressurization of the machine. And once that's closed, fully closed, now I'm about to press the work button, which is this button right here, pressure button. But I'm going to keep my gaze here on the glass. Why? It's very important that as you press this button, which in turn will make it green, you would see that this door is expanding like lungs. So here we go. I'm going to keep my hand here. Notice at the count of 3, when I press that button of operation or pressure button, this door would expand. So here I go. 1, 2, 3. There we go. I witnessed a few things. First, I saw the door visually. It showed me that it expanded. Next, I saw this button turning green, and at the same time, I heard my second motor, which is the compressor motor, kicking in. So all those things combined, I know that my door closed, and now I'm just going to wait for the pressure to show. So let's do a recap. First, I turn on the oxygen, of course with the valve closed. Then I turn the pressure button. That pressure button turned green, and at the same time, my door started to expand almost instantaneously, which gave me the warm and fuzzy that the door seal has been, completed properly. And then the pressurization process began, and here is the demo that it is already started to pressurize. Our pressure, we started at 0, but now I'm at 6 kilopascal. Now that's on the digital scale. 6, what? You just witnessed it. It's at 7 kilopascal. So 7 kilopascal here, 8, and it's going up and up. And now I'll move to the left, to my left, to the mechanical gauge to show the corresponding pressure. So here, I'm at 9, and let's move here to the mechanical gauge, and you would see that the mechanical gauge 2 has started to move. Right there, it is pegging towards clockwise direction. So many people ask us the question, will this mechanical gauge and the digital gauge to my right would be identical? The answer is yes or no. It doesn't have to be exactly identical. It can be plus or minus 4. So you may see, let's say, 45, and it is on the digital scale, and it is perfectly normal for you to see 42 or 40 or 47. So it's normal. There's a range. However, in general, we rely on the mechanical gauge, which is something that we use as a standard, then the digital gauge. And in another video, we will show you how to adjust the digital gauge in case you have the digital figure here and here not matching. So that video will come up shortly. Next component that I would like you folks to pay attention to is the oxygen concentrator and compressor. So since the two functions are combined into one, hence we call this all-in-one machine. Compressor, 70 liter per minute. Oxygen concentrator, 10 liter per minute. Now, how do you turn it on? Simple. All you have to do is in the back, along this location, you'd have a black switch. Actually, it's a black switch with green button. So you turn that switch on, which is up, and immediately after that, you would hear a clicking noise and the motor, the basic motor kicking in. And then when you turn the oxygen button here on the main chamber, you would hear the oxygen pump kicking in right here. So I'm going to keep my gaze here, but I'll keep my ear into the chamber's all-in-one machine. So when I turn this on, I'm expecting a noise, the start of the motor of the oxygen concentrator to start. So let's just go ahead and turn this on. And I immediately heard the oxygen motor kicking in. And now notice, with that oxygen motor kicking in, there is a float. This float is around, it's a little too high, around 9. The sweet spot is between 7 and 8. So I'm just going to adjust it between 7 and 8, like so. So now it's set at the sweet spot. There's one more important thing that I would like you guys to notice is that as you are running the machine, every few seconds, every 4 to 5 seconds, I would hear an expelling noise such as psst. And that noise comes from taking the air, which is the constituent is 78% nitrogen and 21% oxygen, and passing that air through a beads of nitrogen absorbing compound and then expelling it out, and hence you hear that sound. So let's just be quiet and let's hear that sound. There it is. I heard that expel noise. Once again, so every 5 seconds or so, you would hear that expelling noise. It's very important to pay attention during the entire session time. As long as you have the oxygen machine on, you would hear that expelling noise every 5 seconds or so, and that is your litmus test that the oxygen concentrator is running fine. And then the second litmus test is, of course, there is a float, and we kept it at that sweet spot between 7 and 8. So that is, my friend, this is how you would know that your oxygen concentrator is working perfectly fine. Okay, now let's talk about the two most important features that, not most important, two frequently asked questions that we receive from our clients. Not necessarily important, but it's somewhat important. Number one, the function of the ionizer, what it does, and so on and so forth. And the other one is the grounding mat. Now, the purpose of the ionizer, which is inside the internal control panel, top right corner, vertical button. Once again, you have a vertical set of buttons. It is the very top button on the right side along the vertical plane. That ionizer would produce about, I believe, 500 millions of ions in cubic centimeter. Don't quote me on that. I believe that is the right capacity of this ionizer. And it will produce that negative ion inside the chamber by means of a tip. That tip is located exactly at the bottom of those three vertical buttons. Once again, you have along the vertical plane 3 buttons: ionizer, internal fan, and alarm. And right here, you have a tip That tip is covered with a clear tube of about 1/4 inch. And it is that clear tube covered the object under which you would have a horsehair looking brush. And it is that brush which produces the ion. So anyway, you would find ion in nature, either in sea beaches, forests, after the thunderstorm, early in the morning, and so on and so forth. So that's nature's way of producing the ions, the negative ions, which is conducive for better health. And here, by design, we have provided or engineered the ionizer inside the chamber. So my recommendation would be, leave that on. Just let this ionizer be an added benefit for your health while you're using the chamber. So that's the ionizer. The next question that we often receive is the grounding mat. Now, every chamber that we sell, they're equipped with a grounding mat, which has one and one purpose only: to keep your chamber away from any possible electrostatic charge. And should there be any charge, by means of that grounding mat, the charge would be dissipated almost instantaneously. So here is what the grounding mat looks like. This is what the grounding mat looks like from the package. And then you have a tiny little button right here. So the other wire that you would get from the grounding mat, which I'll demonstrate right now, that would have a snap tab. And this is what a snap tab looks like, folks. A snap tab is nothing but a clip. And that clip goes in here, into this place. So you snap that on. And then the other side, I'll take this off for demonstration purposes. The other side, which comes out of the chamber, goes into the grounding port of the wall outlet. Let's recap. You have the grounding mat, which is designed to dissipate the electrostatic charge or charge buildup. This stays at the very bottom layer of your chamber. On top of that, you put mattress, sheet, whatever you want. That must be your first layer. Put this snap tab like so. It would literally snap. And then out from the chamber is this banana clip, and this banana clip should go inside the grounding port of your wall outlet. So our next equipment is the air conditioner. This is the external AC or compressor, and I'll show you how to turn it on. In the back of the AC, you have a black toggle switch. Just simply turn that on. There I go. And notice, immediately after that, this should become lit up, digitally lit up like so. If it doesn't, all you have to do is hit this power button. Once again, you would hit that power button if it doesn't light up and remain black. Now, notice that there are certain digits. There are 3 sets of digits. The very first digit is the timer. We will ignore that as we do not use the timer. Second set of digit is the water temperature. As you know, this is a water-cooled AC. And then your third set of temperature is your set temperature. Here we have set temperature 9, and we have water temperature 14. Now let's go over these icons. Notice the blinking icon. The blinking icon shows you that the compressor is charging up, building pressure, and after a few seconds, once the compressor is ready, this blinking snowflake would become solid, and immediately you would hear a noise coming from this section of the machine. And that would indicate the air conditioner has just turned on. So let's pay attention here. Blinking, and let's wait for a few seconds. Did you notice that, folks? This became solid, and immediately after that, I heard a noise. It is the same noise that you would hear coming from your fridge at night when there's no other noise making the noise quite prominent. So it is the same kind of noise. Once again, recap: 0, the timer, which we do not use. 14.73, that's centigrade, the temperature of the water tank inside here. Next, it is the set temperature, 9 degrees, that we have set up manually to bring the temperature of this unit no lower than 9 degrees. Now, how would you change the temperature, which is set to 9? Well, all we have to do is hit the set button. Here I go. And then using these arrows, manipulate to change it to a different number, such as 10. So here I go, and I'm going to change the number to 10. And after that, I will hit set and set again, back to that same display. Now, this time we have 10 degrees as opposed to 9, and the water temperature 14.52, and it's going down. Additionally, if you want to set the temperature to a fractional number, such as 10.5, which is currently set at 10, all you have to do is hit the set button again, and now manipulate these arrows, and I'm going to set it to 10.5. And then I will hit set, and then I will hit set again, back to that display. Here, we'll show you the water flow. Now, I'll stay quiet, and you could also come a little bit closer so you could see the gentle ripple. Notice the gentle ripple of water flow. That is a positive litmus test that your water flow is running, circulating properly, which in turn pushes the water from inside the tank into the chamber. Keep in mind that in order for the water flow to continue, as you are facing the chamber, to the left of your chamber, you would have 2 blue valves, and those 2 blue valves must be open in the direction of the water carrying tubes. The 2 blue valves that I was referring to are right here. Notice they're in and out. If they're in this position, that is, my friend, no bueno. It has to be in the open position, and all you would do is turn them on and keep them in the direction of the tubes. Here is the tip in the direction of the tube. Here is the tip of the blue valve in the direction of the tube. And that will ensure that the cold water will be circulating through the chamber internal condensing unit through these 2 tubes, which is right here, inlet, and then it goes through the condensing unit's long wound tubes and comes out from the outlet and going back into the chamber. Now, keep in mind that the AC temperature should never be set below 5 degrees centigrade. I have already shown you how to set the temperature by hitting the set button and manipulating the arrows. And once you do that and you would like to bring the temperature, your lowest setting should be no less than 5 degrees centigrade. If you bring the temperature down any further number lower than 5, you may risk freezing the water and in turn potentially cracking the coil. We don't want to do that. So once again, the lowest that you would set, based on what we recommend, is 5 degrees centigrade. And if you wish to change to the higher number, you could change it as high as 12, 13, 15, 16, 18 degrees. There's no issue in terms of the higher number. So just keep that in mind. Lowest temperature, 5 degrees to save your AC. Our chamber has reached 32 kilopascal or 1.3. Now let's 1.3 ATA. Now let's go over the two scales, such as centigrade and Fahrenheit. So here too, we have two separate scales, and they are the scale of pressure. 1.3 ATA is equal to 32 kilopascal. 1.4 ATA is equal to 42 kilopascal. 1.5 ATA, 52 kilopascal, 1.6, 62 kilopascal, 1.8, 82 kilopascal, and 2.0, 102 kilopascal. Now let's take a look whether that is the case. Now we have reached the 1.3 ATA, or 32 kilopascal, and we are going to be verifying whether that corresponds to both on the digital scale and on the analog blue external scale. So here we see 30 kilopascal, and notice that, side note, that your oxygen concentration has also gone up from 21 to 28. So here is the 30 kilopascal, and now I'm going to show you on the mechanical gauge that it is around 32 kilopascal. So here it is. Here is 50, here is 50, next is 30, and then notice it's around 31 or 32. As I said, it doesn't have to be identical, such as 31 there, 31 here. Plus or minus 4, that's perfectly fine. Now, one key thing to note, once it reaches 1.3 ATA, which is corresponding to 30 kilopascal, the access pressure is released from the back from the 1.3 valve. So let's get this summary clear in our head. When you have selected 1.3 and it reaches 30 or 32 kilopascal, any pressure above 30 kilopascal would be released through one of the ports in the rear. We'll show you that in just a minute. If you select 1.4, which is 42 kilopascal, any pressure above 42 kilopascal would be released. If you select 1.6, which is 62 kilopascal, any pressure above 62 kilopascal would be released. If you select 1.8, which is 82 kilopascal, any pressure above 82 kilopascal would be released. Where are they released from? So here they are. I'm at 1.3, so I'm expecting anything above 1.3 would be released from one of the valves in the back. Let's watch that. So here, now that the pressure has reached to 1.3, any pressure with 1.3 button selected in the front control panel would be released from 1.3 valve right here. Here are 5 valves. We have selected 1.3 in the front, and now I'm hearing a sound coming from 1.3 valve. And I'll give you a demo that the sound is definitely coming from here. What I'm going to do, I'm going to cup my fingers around them, and you would hear the sound muffling. There you go. Now that's happening because we have selected 1.3. If we had selected 1.5, then any pressure higher than 1.5 would have been released through here. If we had selected 1.6, any pressure higher than 1.6 would have been released from here. If we had selected any pressure, if we had selected 1.8, any pressure higher than 1.8 would be released from here. If we had selected 2.0, which is the maximum pressure, any pressure above maximum pressure would have been released from here. It's as simple as that. Now let's go over some of the connections in the back. Now this is not an installation video, so that is for the installer. But just know that it's very intuitive. For instance, these connections are written B1, B2, A2, C1, C2, 11, and intuitively the corresponding connections on the other side are also marked accordingly. Either here, A1, B2, C2, C1, and 12, or it would be on the back of the all-in-one machine, such as here. Between these two machines, all wires are connected, either here or here. That's pretty much it. Here, here, meaning the entire machine. Either on that side or between these two, it's all connected here. Now, The 2.0 machine with progressive control would have 2 additional interface, or any machine with progressive control would have 2 extra interface, which is 11 and 12, which is connected here and in the back. Besides that, you would also have the highest pressure valve right here on the back of the machine. Our chamber here is 2.0. That's why the 2.0 primary valve is here and the other 2.0 primary valve is here. So that's how we balance out primary and secondary function of maximum pressure. Should the maximum pressure reach at 2.0 and the primary valve fails, not to worry, it is the secondary valve that would pick up. And if the secondary valve also fails, as I've stated in the other video, it's the tertiary valve that would pick up. So there are a lot of fallback features as part of the safety features, so feel safe. Now, once the chamber has reached the full pressure and you have completed the full session, which could be anywhere between 60 to 90 minutes, and there are different protocol. You can ask for that protocol, and we will be more than happy to share that with you at a later time. But once you basically completed your 60 to 90 minute session at 2.0 or a desired pressure such as 1.8 and so on and so forth, now it's time to wrap up the session. And now we'll show you how to wrap up the session. So, as you notice, I'm at full pressure, which is 96 kilopascal with the button selected at 2.0. Remember earlier conversation? When you're at 2.0, it should be saying somewhere between 1 or 2. But I also said it may not match exactly so long the analog gauge shows 100 kilopascal. And we will show you that the analog gauge is showing 100 kilopascal right here, while the digital gauge is showing 96, and that's perfectly okay. So we've established that you have reached the full pressure and you have stayed in the chamber for a session of 60 to 90 minutes, and now it's time to wrap up. So this is what you would do. You would simply turn on the pressure button and keep your attention for noise, which would be coming from, or rather, which would be going away from the all-in-one unit. So as soon as I press this, the noise of the compressor motor should shut off. So here I go. And now I just heard the compressor motor kicked off. Notice I left the oxygen on. Here is the oxygen button. It is still on. So that means the oxygen port inside is still flowing oxygen through that port at 7 to 8 liter sweet spot per minute that we have set. With that pressure off, it's time to depressurize. General rule of thumb, you should depressurize whatever is comfortable for you. However, the average individual that someone takes without any problem into the aeration tube is between 5 minutes and 7 minutes. You can go any faster. Totally, that is your discretion. If you are an Air Force pilot, if you're a Navy SEAL diver, that's a different story. But for general purposes and general usage, it's usually about 5 minutes. Let's say 5 to 7 minutes. So once that pressure button is off, now we are ready to turn this valve on and begin the depressurization process. How much should you open it counterclockwise? Well, the general rule of thumb is it's about 1/2 inch radial distance. Not, all the way, but 1/2 inch. So here I go, and you would immediately start hearing the hissing noise. So 1/2 inch radial distance. There is 1/2 inch radial distance. Now, once again, there is no hard and fast rule. Whatever you feel comfortable, you would go with that. But you would initially want to depressurize slowly. In the event that you feel the pressure or lack of equilibrium in your eustachian tube, all you have to do is perform those Valsalva maneuvers, such as holding on to your nostrils and And I just heard a pop, even though I'm not inside the chamber. I just heard a pop. If it doesn't happen, do it a little bit more, but not too forcefully. And I heard the pop again. So that would be one. Or you could do swallow. Or you could do yawn. Or you could take your mandible structure and move the jaw mandible structure from side to side, such as left to right. And all of these performed, one of them or all of them combined should release the trapped air and then bring your eustachian tube to equilibrium. Now notice that I started with 100 and now I am down to 81. Either you could verify here, which is right there, I'm around 81 and it's going down, or you could see it digitally, I'm at 79 and it's going down. There it is, 78. So this is a good pressure. Continue to do that. And if you believe that it's a little too slow for you, that's okay. I'm going to open it up just a little bit more. It's fine. As long as you don't crank it out all the way, which will cause a little bit less, a little bit more pressure into your ear, it is perfectly okay. So here I go, I'm depressurizing. It will continue all the way around 11 or 12 or 10. And at that point, once it reaches 10 kilopascal, and by the way, you should be able to view it from inside. So you are witnessing your pressure to come down. And as you see internally that your pressure has come down around 12, 11, or 10 kPa, you could just crank open the valve and then watch the door drop after reaching, few seconds after reaching the 0 kPa. And prior to that, as we've stated, that you should not be touching any of these things. Prior to that, do not touch the door, do not do anything, just let it drop down. And this hissing noise also should disappear once you are nearing the 0 kPa. So recap, depressurization process. You should begin opening up the valve counterclockwise from outside, clockwise from inside, about half an inch in radial distance, and then work your way as you feel comfortable until you continue to go down. Furthermore, if you have to perform the valve salvo maneuver, do so. In the meantime, you're not allowed to touch any of the door mechanism. Continue to monitor the pressure by observing the gauge. Once the gauge is nearing around 12, 11, or 10, at that point, you could crank open the valve, the open-close valve that is, all the way. Then hear that the audible hissing noise is tapering off. Once the pressure says 0, a few seconds, maybe 10, 15, 20 seconds later, you would not hear that hissing noise at all, at which point the door should drop automatically. Once the door drops, use the golf grip ball mechanism, exert about 5 to 7 pounds of pressure, and push the door from this side to that side, and then pay attention not to touch any of the internal door mechanism, and touch only the 2 door handles as you need. You may put your body weight here. That is perfectly okay. But other than that, you should not be putting your body weight, should not tug, pull, press, and pry any of those as you are exiting out of the chamber. Now, as you are exiting out of the chamber, you may have an urge to go to the bathroom. That is completely normal. And hence, as I said, you should finish your bathroom business before you go inside the chamber. So that is pretty much it. If you folks have any further questions, reach out to us and we'll be more than happy to give you any further assistance that you need. Thank you.